Hello and welcome to my video. Today we are going to solve the following problem in two similar but slightly different methods. The core principle is the same, but the details in approach is slightly different. So the problem is find the coefficient of x to the power of 8 in the expansion of the following polynomial. Okay, now I am going to show you the first method. And actually, let us write this polynomial as like this. Here, terms in the expansion of this polynomial come from selecting one term from the first polynomial, one from the second polynomial, and one from the third polynomial. Like this. So now consider selecting x to the power of a from this polynomial, x to the power of b in this polynomial, and x to the power of c in this polynomial. If we want the resulting term to be x to the power of 8, then a, b, and c must satisfy a plus b plus c equals 8. Here, a, b, and c are integers satisfying these ranges because we have 7 here, and 4 here, and 4 here. Now let us examine the number of solutions to this equation by varying the numbers. So let's start by varying a. So a can have these values. Now let's start from a equals 0. Then we have b plus c equals 8. So therefore, possible values for b and c is, by this range, we only have 4, 4 as the solution. So if you count how many ways, we only have one way here. Next, a equals 1, then b plus c equals 7. Then the possible values for b and c are 4, 3, or 3, 4. So here we have two ways. And when a equals 2, then b plus c equals 6. So b and c are 4, 2, 3, 3, and 2, 4. So we have three ways. When a equals 3, b plus c equals 5. So now we have 4, 1, 3, 2, 2, 3, 1, 4. So we have four ways, and we can go on and on. And like this. So these are all the solutions. And the coefficient of x to the power of 8 is simply the summation of number of solutions. So if we add them up, we have 24. And this is the coefficient of x to the power of 8. So that was the first method. Okay, now I will show you the second method. Here, let's call this given polynomial as px. And here, for this part, you can see that from 4 and 2, this part is the polynomial of degree 8. So let us write this part as a0 plus a1x plus a2x squared plus a8 x to the power of 8. That is, we have expanded this polynomial without actually calculating the individual coefficients. Then we can write px as 1 plus x squared plus 2x to the power of 7 times a0 plus a1x plus a2x squared plus a8x to the power of 8. So now here, the fair question to ask is, why do we do that? Well, since px has now reduced to the product of only two polynomials, it became easier to check when does x to the power of 8 appear, because now we choose two terms, one from here and one from here, instead of 3. So it became easier to, count things. Okay, so how does the counting works this time? Well, the x to the power of 8 term comes from, so if we choose x7 here, then we must choose a1x here to obtain x to the power of 8. So one possibility is choosing x to the power of 7 from the first one and choose a1x to the second polynomial. And if we choose x to the power of 6 here, then we have to choose a2x squared here. So another possibility is this, and you can see where this is going. The next choice is x to the power of 5 and a3x cubed all the way to the final case is choosing 1 here. And then we have to choose this term, a8 x to the power of 8. So these are all of the possible choices that gives x to the power of 8 terms. So from here we have coefficient a1, and here we have coefficient a2, we have coefficient a3, and finally we have coefficient a8 here. So the coefficient of x to the power of 8 is simply a1 plus a2 plus a3 plus a8. And we can quite easily compute this sum without having to expand the polynomial. Let's take a look at this again. Notice that this is an equality, or sometimes we call it identity, which means that it holds for all values of x. That is, we can let x be whatever values we want it to be. So in order to calculate this, let x equals 1. Then we obtain, on the left hand side, it is 5 squared, and on the right hand side, it is a0 plus a1 plus a2 plus a8. So comparing with this, we have additional a0 here, while this is the coefficient of x to the power of 8. So in order to find a0, now let x equals 0, then we have 1 squared equals simply a0. And if we substitute this a0 with 1, we finally have coefficient of x to the power of 8 as 5 squared minus 1, which is again 24. So this was the second method, and although the first method is more general or well-known method, the second method here actually seems to take less time than the first method, at least in my opinion, so I thought it is worth mentioning here. And that was all for this video. If you like this video, please hit like and subscribe, and I will see you with another video.